Let us look at horizontal shifting. In this example, I did two examples on one page, and if we look at the first one, which is cos of theta plus 45 degrees, then we notice that the A is 1, the B is also 1, but the H is negative 45 degrees because I must have plus minus to get to the minus H. We have in the formula we have minus H, so it's negative 45 degrees. So let us first look at this example. So in this case our K is also 0. So we did not shift up or down. So let us first look at, if I take a value 0 and I add 45 degrees, I will have to go to 45, read off the 0.7 and plug it in here. So you see the direction there. If I go to 135, if I add 45, I get 180, go back to 180, read off 1, plug it back here. So my direction is like that. If I go to 225 and I add 45 degrees, I get to 270 degrees, I go back there, read it off, which gives me 0, and that I plug in here. So my direct direction here, my direction is there and there. So it's 1 unit, in this case 45 degrees back, that we get the graph. Although we plus there, because the H is negative 45, we move backwards. So if I look at my graph here, I'll see that at I, which is minus 45, if I add 45, I'll get the value at 0. And I'll use that value and make a dot there. And so forth, and so forth. So this is for the cos 45. So you can see everything that's moved. So this is the 45. Let me do it in red. So this is the dots for the cos theta plus 45. Okay, so if I now move to the other graph, let us take another color. Let us take purple. Then we see, okay, here again we have A is 1, the B is also 1, the H is now plus 60 degrees because it's minus H, so H is plus 60 degrees and K is still 0. So if I look at take 60 degrees and I subtract 60 degrees, I get 0. So now I have to go to that value, which is 1, and put it back here. And for 180, I will subtract 60, so I'll get it 120. So I'll go to 120, collect the value, and plug it in there. And the same with 300 degrees, I will subtract 60 degrees, and I will go to the 240, get its value, and plug it in there. So if I just have another color there, then you'll see everything moved to the right. And that will be these dots, the dots that's 60 degrees to the right of the green graph. In the case of the two graphs here, the red graph is the one that shifted 45 degrees to the left, and the purple graph is the one that shifted 60 degrees to the right. So if you have a negative here, the graph shifts to the right. If you have a plus here, the graph shifts to the left. And it comes from writing this theta here, theta minus 45 degrees. And here we have theta minus plus 60 degrees. So please look at the values here, and we will notice that the shifting did not change the period, it did not change the amplitude, it just shifted the whole graph to the left or to the right. And because of the grids here, you can read off the roots, and you can read off where you find the extremes, or you can remember what the original extremes were from the graph, the regular graph or the mother graph, and just get it in the one case 45 degrees to the left, in the other case 60 degrees to the right. For an exercise, you can now solve or find the roofs algebraically by solving cos of theta plus 45 equal to 0 and solving cos theta minus 60 degrees equal to 0. That is a very good exercise, and you will also notice how the shifts happen the moment you get the original solutions. Remember, you can put that theta plus 45 equal to one symbol like a capital X, and that to a capital X, and then solve it like that with the regular function or the mother function, and then you will just see that that plus 45 goes to the right, so you subtract 45, and the plus minus 60 goes to the right from the equality sign, and you will have plus 60 degrees.